For most of human history, staring up at the night sky led to a logical assumption. The universe was a static, eternal, and unchanging void. The stars we saw tonight were the exact same stars our ancestors saw thousands of years ago, hanging motionless in the dark. That illusion held until the 1920s, when a mathematician and Catholic priest named Georges Lemaitre proposed a radical theoretical alternative. He suggested the universe was expanding, and if you traced that expansion backward, everything must have originated from a single, highly compressed point, what he called the primeval atom. Around the exact same time, Edwin Hubble was working with a massive new telescope in California, moving Lemaitre's math from pure theory into observational reality. This diagram models Hubble's specific physical discovery. The surrounding galaxies are actively moving away from us in every single direction. The physical space between them is growing. If everything out there is currently falling apart, what happens if we logically rewind the cosmic clock by 13.8 billion years? Witnessing the singularity firsthand is impossible. To understand the beginning, we must trace the state of the universe through the physical remnants still visible in the sky today. We start that rewind by looking at this chart, which breaks down the current elemental recipe of the universe's normal matter. You'll see it is lopsided, roughly 74% hydrogen and 24% helium, leaving only a tiny sliver for every other element combined. Physicists call this process nucleosynthesis. The math dictates that for this exact, heavily skewed ratio to exist today, the early universe had to act as a brief, intensely hot forge during its first few minutes, fusing the absolute lightest elements before things cooled down. Stepping further back, if the entirety of the universe was once compressed into a microscopic space, the friction and density would generate blinding, infinite heat, and a fire that big should leave residual energy cooling across the entire sky. In 1964, astronomers Arno Penzias and Robert Wilson found that exact residual energy completely by accident. They were using the massive Holmdel-Horn antenna to conduct radio experiments, but they kept picking up a faint, persistent static. It wasn't coming from a specific star or galaxy. It was omnidirectional, coming from absolutely everywhere at once. That static is the cosmic microwave background. It is literally fossilized light from 380,000 years after the beginning, released the exact moment the universe cooled enough for the first atoms to form. We have a precise hydrogen-helium ratio, and we have an ocean of fossilized light blanketing the cosmos. These two measurable phenomena confirm that the universe evolved from a highly compressed, intensely hot state. So, let's take it all the way back, T-0, the Planck era. The entire universe is compressed into an infinitely dense singularity, and then it expands. Standard definitions of explosions fail to describe this event. Rather than matter blasting into a void, the Big Bang describes the sudden emergence of space itself. This visual abstraction shows what physicists call inflation. It is the violent, faster-than-light stretching of space itself. The matter isn't flying through space. The grid of space is expanding underneath it. Because space itself was doing the stretching, the Big Bang didn't happen at one specific location. It happened everywhere all at once. There was no empty room for the universe to expand into. The dimensions of space and the flow of time were physically generated by the event itself. If you try to picture a conventional explosion, the physics of our universe's birth will never make sense. We have to completely break our earthbound intuition to understand what actually happened. Look at this composition chart of the universe today. Normal matter, stars, planets, us, makes up just 5%. About 27% is dark matter, the invisible gravitational glue holding galaxies together. The remaining 68% is dark energy, an accelerating force actively driving the expansion of space. The expansion that began 13.8 billion years ago never actually stopped. We are living inside an ongoing process. The universe continues to stretch, pushing galaxies further apart with every passing second. Reverse engineering the Big Bang provides the physical mechanics of our origin, but the math points both ways. The exact same expansion mechanism that ignited our cosmos is actively dictating its final, accelerating fate.